Hi folks, so the question we're faced with here today is from the 2014 Junior Cert paper higher level on the ellipse and the parabola question, which is always going to be question 6 on the higher level paper. As you can see, the image we are given is a picture of a cat where the cat's face is in the shape of an ellipse and then the cat's body is in the shape of the parabola, and we have another little bit of a parabola over here. But anytime you're starting off one of these questions, always starting off by reading the information that they give you here as well in front of you, just in case you miss out on something. So that's where we're going to start today. So it says, the figure shows a logo for an animal shelter. The curve ABC is a parabola with vertex at B. So we have A, B, C. That's a parabola with the vertex at B. So that's my axis line running down there, down the middle. It then says the curves DEF and GHF. So we can see here D, E to F and G, H to F are identical portions of the same parabola ABC. Okay, so they're identical portions of this first parabola. With vertices at E and H respectively. Okay, so we'll have to do maybe a little bit of either axial symmetry or cuts along there to get that, or we could just draw in the parabola again. Then it also says the curve JKLM is an ellipse with focal points N and F. So JKLM, and then we've also got focal points that are called N and P, which we can see here. And it says draw the given design showing clearly all constructions. Okay. So often on these questions, usually the starting point would be to start with the ellipse, but in this one we can see the ellipse is actually at an angle, okay, whereas we can see the cat's body and feet are obviously based on a flat surface down here on the ground. So I'm actually going to start on this one by drawing out the parabola. And anytime we're drawing a parabola, what we're going to use is the rectangle method. So I just want to make sure I have the height of the parabola. Yeah, I do. From here to here is up 110, so that's my height of my parabola. And then I've got half of it here from B to C, I can see is 70 millimeters, and then 58 and 12 would be 70 on the other side. So I can do a simple rectangle around here, just heavy that in there up to B, parallel line up here. And what I'm going to do is, with that rectangle, I would split it up into equal portions. So just on the 70 there, so that rectangle, I'm going to split it up into equal portions. That's my B line is my axis, because B, as it told us, was our vertex. So 70 and 110, trying to think of something that will divide in there. 5 goes into 70, 14. So I go 14 5 times, 14, 14, 14, 14. And what I would do is I would transfer them down vertically like that, because that's the direction of our axis. Okay, obviously I haven't measured it accurately here, but this is just for demonstration purposes. And then 110 divided by 5 would be 22. So it would be 22, 22, 22, 22. And all of these points essentially then would join to our vertex, which in this case is B. And that will help us locate points on our parabola, essentially. Okay, so you can see how some of them are kind of coming there. Okay, so that's the idea. That's where we're actually going to start off. Okay, so I'm going to start off by drawing the parabola ABC and getting the feet part in here. We can see this foot here from A, it's in 12 and has a radius 25, and this foot is on C and it also has a radius 25. So I'm going to start with that there now. Okay, so as you can see on my sheet, I've already drawn in my rectangle, which is 110 high. And I've measured out from the center of it, I've measured out 70 here this side and 70 here this side. I know from A, just for that foot part, it's in 12 millimeters, so I just find my center there, just to have it got. I'll actually draw in those little feet there now, first of all. So from the center, and then it was a radius of 25. So just put that in there first of all, just to have those little bits done. So from C I had 1. Which was radius 25 here, so just pop that in there. Some little foot there. I'll heavy him in a while. So that's 1 foot. And then the exact same here on the opposite side. That'll just help me later on when I'm putting in my final detail. Okay, now what I want to do is draw on the parabola. And I said along, I'll actually do it up here. 70 divided by 5 was 14, so 14 and 14 would be 28, and 14 would be 42, and 14 would be 56. So they are going to go vertically, those lines, parallel to my axis, which was B, the B line down because B is our vertex. So nice and light, keep the drawing neat and tidy. And then measuring down along the sides, 22s, because 110 divided by 5 is 22 and 22 and so on. So 22, 44, 66, 88. So 90 back 2, be 88. Right, and at this point now, what all I'm going to do is connect every one of these points to B, which will help me locate points on my parabolic curve. Okay, and as you can see there, I have located some various points on my parabola. That would be one, where the top one up here goes to the closest one into B. The second one will be the second one out from B. So you can see the second line down, third line out from B, be here, fourth, there. As you can see, there's my parabola. So what I'm going to do is I'm going to sketch in that curve there very quickly, and I'll use a little bit of axial symmetry along the axis to get these points on the opposite side. Okay, so I'm just going to speed up the video there now. Right folks, so the next portion of this question, as we can see there, actually I just did the curve ABC, and I got the two kind of paws of the cat as well, got in there as well, okay? I haven't heavied in any detail yet, I've just put it in all likely at the moment because there is obviously portions of the parabola at this moment in time, up here especially, I don't know exactly where this point and this point are where I'm going to start heavying in. Okay, I could have heavied in these, but I'll just do them later on. Now what we're getting onto is the curves DEF and GHF, okay, and these are identical portions of the same parabola that we've drawn. So there's a couple of ways that you could actually do this. To get the DEF one, we could follow the exact same method because obviously it's the identical ellipse, or identical parabola, sorry, so it would have the same dimension out here, which is 70, okay, and then it would have the same height, and as we can see, E is at the same height as B. But all we have to note is then is from C, just to locate E, is the first thing we're going to do is from C, it's out a distance of 45 and it's going to be at the same height, okay? So that's the first thing I'm going to locate there. Just want to find where is my E. So from C, it's out a distance of 45 millimeters. So just measure that there. 45. And at that 45, project the line up. And project this line across, and what I have located there in that exact position is now my position of E. Okay, and to locate H then as well, it's down at an angle of 45 degrees from E, and it is out 10 millimeters extra as well. So 10 millimeters extra out here. So just measure out 10. And once again, project the line up, and that there is going to be my H at that point there. Okay, and they'll both meet at the point F as well. Okay, so the curve I'm going to focus on first of all, just bring back this sheet here, and I'll zoom in. The curve I'm going to focus on first of all is the curve D up to E down to F, and then I'll focus on GHF, okay? So DEF first of all. What I can use here is I could do the exact same method as I did over here by drawing in a rectangle, okay? I could from E come down and then I could measure out 70, okay? And draw in that portion of the parabola here obviously until it cuts the main body of the cat, so I wouldn't need it going all the way down here. Or another way I could actually do it is I could just take some measurements from my parabola here, because it said it was an identical portion of the parabola. So I could take some measurements from here. I could do like cuts, okay? Because I've got a series of points already. If you imagine this was a point on my curve right there, and if I was to take a cut across the curve, I'd have the distance from the axis to that point on the curve, either side for the parabola. So I'd have this distance here is the same as this distance here. Okay, and I could take that and I could transfer it across, and literally transfer it across, and then from this point here, where E, because E is going to be my axis line and E is a vertex, I'd take that distance and measure it out this side, and it would give me a point on my parabola. Okay, so that's the method we're going to use there to be able to get the curve DEF first of all. Okay, so I have a couple of cuts already got. We'll just zoom out there again so we can see it. And as you can see, I have a couple of these cuts, so I'm just going to use where the points were originally. So I'm going to transfer that one across, this one, and take this one, and we'll see how we get on with that. And all I'm going to do is, from where these points were, where these points here hit the line, okay, my E-axis line, I'm going to take points here, these distances, on my compass, and I'm just going to mark it out. Very simple, rather than going through all that work again. Okay, so mark that out, nice and quick, so I'll just speed up the video there. Okay, so as we can see there, I have now kind of got my DE, and I don't know the exact positioning of F just yet. I will only find F when I get the parabola GH, okay, and continue it on. And it's where the parabola GHF cuts the parabola DEF, and they'll cut to give me the point F right there, okay. So what I need to do right now is do the exact same method, okay, that I did here for DE, okay, the DEF parabola. I'm going to do the exact same method for the GHF parabola, only this time, because the parabola here in this case has moved down a distance from here down to H, which is here, I'm going to have to calculate that distance down. So from H, what I'll do is, let's say for this point here, I would take the distance from B down to here, that distance down, from there to there, okay, I'll just put in an arrowhead there, from that distance there, and I would step that down. And once I've stepped that down, all I would do then is take that distance out, same thing again. And that's how I'll work out my points, okay, for the parabola here. Okay, so that's what I'm going to do there. Same thing for the next 4 points. Okay, so just show you that there now. So what I'm going to do is for H, I'm going to step these distances down here. Okay, so the distance from there to there, the distance from there up to here, the distance from the top down to here, and the distance from the top down to here. And that hopefully will get me, just looking there, might need a couple more. I might take another one just about here. Take that cut as well, okay, and that distance down there as well. Okay, so that's what I'm going to actually take, and I'm going to step those distances down. Now this one is quite small, so it's a little bit awkward, so I'm just going to measure that one, and it's working out to be just under 5 millimeters. So from H, I'll just measure that down, same thing, just under 5 out there. Then I'll step down the next one. I'll use a compass for the rest of them. So this distance down here, and step down from H. Then I'll use same thing and so on. That distance there, step it down from H, and just continue the process. Might need one more. So there we go. Now what I'm going to be doing is getting these points here. Okay, so there's this one here. I'm going to step that out because I know there's a point on my parabolic curve over there. Step this one out. Step this one out. This one out. And then step this guy out as well. Just give me an extra point. Okay. And now what I'm going to do, the exact same process. Take the measurements that I took previously. This one here is going to be along this guy. and so on. I should have actually marked it the other side as well, just save me a bit of time, and mark it out the opposite side. We can see we're getting close to where F would be, somewhere in around here. And now the same thing for the next point, which is here. Next one down, which is here. Next one down, which is going to be here. Just have to move that line out a little bit further to meet it. There we go. And the very, very last point, then I took an extra one. Just in this case, I wasn't sure if I was going to need it. Hit my curve there, project it down, it's going to be down to here. So what I'm going to do now is very quickly just sketching that parabolic curve, so I'll speed up the video on this bit. Okay, as we can see now, I have actually completed all my parabolas. I've got the parabola ABC, I've got the parabola DEF, and I've got the parabola GHF. So just at this portion of the question, what I'm going to do is I'm going to heavy in all the bits I can down here, and I'll heavy in a little bit of this up to here and a little bit up here, but I'll leave the portion at the top blank, because I know I have to put in my ellipse there. So I'm just going to speed up the video to get that little bit heavied in. Okay, so the next portion of this question is on the ellipse. So the ellipse, it said, was the curve JKLM is an ellipse with the focal points N and P. So first of all, what we need to do, anytime we have an ellipse and we need to be able to draw one, we need our major and our minor axes. Okay, so looking at this ellipse, I can see that my major axis is running in this direction from J over to L, which will contain the focal points N and P. So that's my major, which is running in a kind of angles left to right direction. And my minor is going from K down to M. So that's my minor, which is going in an angle direction almost vertically. Okay, but what we can actually see, just to be able to locate them in our start point, from where the cat's footprint was here, or the paw down here, it tells us this line here, from this point here, it goes up at an angle of 60 degrees. Okay, so that's how I'm going to be able to locate this line here. Okay, and then from B, it's kind of hard to see there, but from B to locate M, it's going to be down 20, and where that from B down 20, where it cuts that, that's going to help me find M. Now, to be able to draw this ellipse, we have to see, are we given the distance of the major axis? And no, we are not. It doesn't tell us. Okay, it does tell us the focal points and how far they are out from the center. It tells us 25 and 37 would be 62 out either side for the focal points. And it does tell us the minor. Yes, it does tell us the minor, because the distance from the center of the ellipse down to M is 50. So we have the minor axis, we have the radius, which is going to be radius 50, because it gives us that. We do not have the major, so MAJ question mark, right? But we do have focal points, okay? And if we have the focal points, we can use the methods to find the major, because often when you have the major and the minor, you say half the major from the top or bottom of the minor will help us find our focal points. So now we're just going to work backwards. So we have our focal points, we have our minor, so I can take the distance of the major as being the distance from M to N. So I would get that distance on my compass, so I'll just show you there. I'll take the distance from M to N, or M to P, or K to P, or K to N, but I would take that distance there. In this case, I'm going to say just M to N, take that distance, and from the center, which I have, that will show me where J is. Okay, and I should be able to draw in my major circle, which would be going around like that. Okay, that'll help me then draw my ellipse later on. So I have my major, I would have my minor, which would be like that. And now I'll be able to draw my ellipse using the concentric circles method. Okay, so just going to put in that information there now. So 60 degrees from here, down 20 from B to locate M. So, just zoom out there a little bit. So, from this point right here, I want to project up at a distance of 60 degrees. Okay. And from B, I know it was a distance down 20 millimeters. So we'll just mark down from 60, it'll be down to 40. And where that cuts through, right there, that is my point N. I'll just write in that. And from there, I know up that, along this line, 50 millimeters is going to be my minor axis. The center. Okay, so that's going to be my center. So from here up to this point I measured up 50 millimeters, and then 60 plus 30 degrees, because the major and minor axis are always going to be perpendicular to one another. That means that's my major axis. So I will just write in, I always do this in class, when I write in my major, MAJ, and it's going in this direction, and M, I'll just put in, M stands for the position of the ellipse, but I'll just write in MIN for minor, and I know my minor is going in that direction. Okay, I'll just use them as a guide later when I'm using the concentric circles method. So at this point here, I can draw in my minor auxiliary circle, just to have it done and out of the way. So from here down to M, put in my minor auxiliary circle, and also locate the positions of my N and P and K. And I've already found K there, because K will be up at the top of the minor. And now I want to find N and P, and I calculated N and P to be out a distance of 62 out from the center. So 62 out there, and then 62 out the opposite side is going to be P. There. So that's my distance for N, that will be P. And now, as I said, half the major axis from the top or bottom of the minor will give me the focal points. In this case we have the focal points and we have the minor, so we'll work backwards. So we'll just take the distance from M to N. And that distance there on my compass is going to equate to the major axis. So I'll just take that distance, put in my major auxiliary circle, and I will be able to find J and L. Okay, so at this point here, I've got J, I've got L. I can now draw in my ellipse using the concentric circles method. And just show you one of the ways of doing that there very quickly. If I wanted to find 2 points on my ellipse, or yeah, I'll find 2 of them. So I'm going to split my ellipse up into 12 segments by doing 30-60 degrees through the whole ellipse. But in this case, just to complete that, that's why I wrote in my minor down here and my major here. Where it cuts my minor circle, which it cuts right here and here, I'm going to go parallel to my major axis. Okay, and I know my major is going at an angle of 30 degrees in this case. So I go 30 degrees that way, 30 degrees this way. Where it cuts my minor circle, which is right here and here, I go, or sorry, where it cuts my major circle, there and there, I go parallel to my minor axis. And I know my minor axis is at 60 degrees. So I'll project that one down, and this one up at 60 degrees. And that has helped me locate 2 points on my elliptical curve, right here and here. Okay, so I'm just going to speed up the video there now to complete the rest of this using the concentric circles method. Okay, so just speed up the video there now. Right, at this point here, now you can see I have completed my ellipse, and all I have to do actually at this point here is fill in the details for the rest of the drawing. So as we can see here, the cat has a little bit of a kind of smile here. It has triangular nose here for the nose, or triangular nose. It has circular eyes, and then it obviously has triangular ears as well. Okay, so what I'm actually going to do, and then these whiskers down here as well, they're at an angle, so just using the protractor 24, 6 and 6 degrees, same at the opposite side. Okay, so just to be able to complete the rest of the question, I'm going to speed up the video there now and just putting in the details. Okay. Right, as you can see there, that is the question completed. Quite a lot in that question actually. The parabola was the main bulk of the question here in this case. Usually on these questions, a lot of the kind of problems that are associated with would mainly come from the ellipse. The ellipse portion of this question actually wasn't too hard because they gave us the minor axis, they gave us the focal points. We just did a little bit of backwards work from our understanding of the half the major from the minor gives us the focal points. We had the focal points, therefore we measured from the focal points to the top of the minor or the bottom of the minor, and we were able to work out the distance for our major axis. From there, simple concentric circles method. Just a lot of tidying up here around the cat's face just to get in the details, okay, in here, especially for the eyes, the ears and so forth, measuring out the certain distances and the whiskers. The parabola then, obviously, being able to take one parabola and take identical portions of that parabola and just transfer it over to another part of the question. Hope you found that question helpful there once again. That is the question completed there. Thanks.